Alrighty, boys and girls, welcome to our second video lesson, lesson 6-4. Let me grab my pointer. Lesson 6-4, our video on transformations of exponential and logarithmic functions. Okay, just to review for a quick second here, our basic exponential function looks something like this. It's going to be asymptotic on the left-hand side of the y-axis. It goes through the y-intercept of 0, 1, and then it shoots up quick. We know that the base cannot be 0, the base cannot be 1, and the base cannot be a negative. If the base is a fraction, we know that our exponential function is going to be reversed. It looks something like this, okay? But I'm not going to draw all that in because I want to keep just our basic exponential function. But there is our exponential function. If the base is a fraction, the domain of an exponential function is all real numbers, the values of x, and the range of an exponential function is all positive numbers, If I reflect that over the line, y equals x, so let's draw in a dotted line of y equals x. Looks something like that. We can now draw our logarithmic function, our basic logarithmic function. It has an x-intercept of 1, 0. Just like the exponential function that shoots up very quickly, the logarithmic function is going to shoot to the right. Just like the exponential function hugs the x-axis on the negative side, the logarithmic function is going to hug the y-axis on the negative y-axis. Okay? Just like in an exponential function, the base of a log cannot be 0, it cannot be 1, it cannot be negative. If the logarithmic base is a fraction, then our graph is going to be this thing. I'm not going to draw it, but it's the same idea. It hugs the positive y-axis, goes through the point 1, 0, and then it shoots off to the right. Okay? What is the domain of a logarithmic function? Its x must be greater than 0. It's all positives. What's the range of a logarithmic function? It is all real numbers. Get these into your notes, and you guys know these from before, all the transformations we've been doing. The a, the number in front of our exponential function, is the vertical stretch. If it is a number bigger than 1, if it's a fraction, it squishes it. It is a compression. If a is negative, it reflects it over the x-axis. Our b is our rate of growth, right? It's our rate of growth right here. The bigger b is, the faster it gets bigger. Okay? If b is a fraction, of course, we reflect over the y-axis. Okay? The h, just like in all of our other transformations, h is our horizontal shift. Remember, h looks opposite of what it is because it's x minus h. And our k is our vertical shift. It also represents our horizontal asymptote, right? And our critical point, we're going to call that the original y-intercept is always going to be h, comma, k plus a. Okay, let's graph this guy right here. G of x is equal to negative 3 raised to the x power. And again, this negative is not being raised to the x because we can't have a base of a negative. So this is negative times 3 to the x. Here is our basic exponential function, y equals 3 to the x right here. Okay, and it passes through that point 0, 1. So looking at this function now, what is our a, what is our b, what is our h, and what is our k? Well, let's figure this out. The a is actually negatory 1 because it's negative 1 times 3 to the x power. Our b is our base, which is 3. And h and k are both 0 because I don't see anything written with my exponential term. Okay, so now what happens to this graph? This graph just gets flipped over the x-axis, so it's going to look something like this. It's going to go through, it's going to have a y-intercept of 0, neg 1, hug the x-axis on the left side, pop through there, and then shoot down to the right very quickly. Alright, here's our next one. G of x is equal to a base of 1.4 raised to the x power plus 2, and this plus 2 is not in the exponent. You guys fill in the a, b, h, and k right now, and I shall be right back. For a bonus point, email me who said I shall be back. Email me. It's a historical question. You can email me for a bonus point. First three people to email me with that bonus point. Okay, you should have found that a is 1 because there's nothing in front of our exponent right here. So a is 1. B, our base is 1.4, so it's going to grow, but not quite as fast as like a 2 or a 3 or a 4. H is 0, there's nothing in the exponent with the x. And k is 2. I have an extra plus k right here, plus 2. So my basic exponential graph would be, again, this piece right here. And then it shoots up. It's not going to shoot up quite as big as some of the others. But now this whole thing is just going to move up 2. So I'm going to draw a new asymptote at y equals 2. This ordered pair of 0, 1 now becomes 0, 3. It's going to hug. We'll do it in yellow. It's going to hug the new asymptote, go through the point 0, 3, and then it's going to shoot up like the other one did, but 2 spaces above. Okay, this third one right here, g of x is equal to 2 times 5 to the negative x plus 3. Let's go through and fill in our a, b, h, and k, and there is a trick here. Okay, the a, of course, is very good. You guys got it, 2. The b here now, I'm raising 5 to a negative exponent. When I raise a number to a negative exponent, I'm taking their reciprocal. So we can almost think of this as 5 to the negative x as 1/5. My b is 1/5 raised to the x, because 5 to the negative x is equal to 1/5 raised to the x. So our b here is in essence 1/5. Okay, our h again is 0, and our k is 3. So when we do this now, we're going to have a climb of 3. We're going to have a stretch of 2, and our graph is going to flip over the y-axis. So if we want to think about it like this, I'm looking for a marker. Boom. Our basic exponential function, where it's reversed, where we have a fraction of a base, looks like this. Where this ordered pair right here is 0, 1. Well, now our new asymptote is going to be at 3. Okay, and we are, as opposed to going up 3 to 4, we're actually going to go up 3, and then we need to double our intercept. So our intercept is actually going to be at 0, 5, and then it's going to climb up like it did before. And to help you find that intercept, you can always plug in 0 for x. So if we plug in 0 for x, we're going to get y is equal to 2 times 5 to the negative 0 power plus 3. Well, 5 to the negative 0 is 5 to the 0, which is 1. 2 times 1 is 2 plus 3. And so we can see now that our intercept is 0, 5. Alright, you guys try these right now. I want you to match up these graphs with these curves. I know it's a little bit confusing, but this is the A curve, this is the B curve, etc. Note, functions may not necessarily be drawn to scale. Okay, so f and n dts, functions not necessarily drawn to scale. Okay, so stop the tape, do your best to match these functions up, and I shall be right back. Okay, you should have gotten that the first one is D, the second one is B, and as you look at D and B, they both go through the ordered pair 0, 1, so there are regular exponential functions, but B gets bigger quicker than D, so therefore the first one, 2 to the x, is D, and the one that gets bigger quicker is 10 to the x, so that would be B. C is the exact same graph as the first one, except it has a rise of 2, so it's going to be C right here. Okay, 4 is 2 to the negative x, so that's like 1/2 to the x. It also has it also goes down 3. It goes down 3, so it's reversed. So it's going to be the A graph right here. And it goes down 3, so it goes through the ordered pairs 0, 2, and it's a fraction, so it's reversed. It's going to hug right here. And the last one, we have an A of a -1 and a climb of 3, so it's upside down. It's E, it's an exponential graph that's upside down, and it has a climb of 3, so the asymptote is still at 3. Alright folks, we're almost done. Why don't you just copy these into our notes, okay? Copy these into our notes in our note packet. Again, it's very similar to all the other transformations we've been doing, okay? So copy these into your notes, and I shall see you mañana. Adios.